Per- and polyfluoroalkyl substances, otherwise known as PFAS, are a group of man-made forever chemicals that have been in use since the 1940s. PFAS are used in the production of thousands of consumer and industrial products, including non-stick cookware, waterproof clothing, firefighting foams, and food packaging. The extreme water, heat, and grease resistance that makes PFAS good for so many different applications is also the reason for their persistence in the environment after being introduced by industrial and residential waste, wastewater treatment plant effluent, stormwater runoff, and various land applications. I collected water samples from 3 sites along Streets and Sawmill Run, as well as individual samples from Lowry's, Gertie's, and 9 Mile Run. These watersheds all have different degrees of urbanization and different proportions of developed to forested land. Samples were analyzed for 40 analytes of PFAS and their precursors using EPA method 1633 for PFAS detection by liquid chromatography coupled with mass spectrometry. In the future, a macroinvertebrate survey will also be included to test the bioaccumulation of PFAS in our streams. PFAS was detected at all 9 sites with concentrations ranging from 23.3 to 64 nanograms per liter. The highest levels showed up near regions of greater industrial development like Streets and Sawmill Run, while the lowest levels were found in the more forested Lowry's Run. This pattern isn't a coincidence. PFAS enters rivers through sources like wastewater discharge, firefighting foam runoff, and industrial sites, all more common in developed watersheds. This lines up with dissolved metals data, which found elevated levels of iron, manganese, and copper in Streets and Sawmill Run, which are common indicators of pipe corrosion impacting the water chemistry. These preliminary results suggest a possible link between land use and PFAS levels, with higher concentrations near more developed watersheds. However, more sampling is needed to confirm this trend. Moving forward, incorporating surveys of sediment and macroinvertebrates will help us better understand how PFAS may be accumulating in our stream ecosystems.